To work out this Boyle's Law problem, we first need to make sure that we know the equation for Boyle's Law. Boyle's Law is P1 V1 equals P2 V2. So what does that mean? It means that we're initially going to have a set of conditions for pressure and volume that we're going to start with. So we call those the initial pressure and volume, or the starting set of pressure and volume values. Then what we're going to do is we're going to get a second set of data after a change occurs. So that's going to be our P2 and our V2, second set of conditions. So again, this happens after a change. We can also call those our final set of conditions. So let's go ahead and read this problem to identify what the starting or initial pressure and volume is. It says a balloon has a volume of 250 milliliters at a pressure of 202.6 kilopascals. So kilopascals is probably a new measurement of pressure for you. It's kind of like PSI that would fill up your car tire. So kilopascals is another unit of pressure. So let's go ahead and plug in those values. So we have 202.6 kilopascals, and we, for volume, have 250 milliliters. So that's our P1 and our V1. The next thing we're going to do is we're going to look for the pressure and volume after a change occurs. It says, what will be the new volume? So that's our question. We're going to be looking for that new volume, or V2. It says, of the balloon in milliliters, if the pressure is changed to 810.4 kilopascals. So again, we're working in kilopascals, so the units of pressure are the same, kilopascals for the initial and the final set. So I'm going to plug that pressure in for my P1. Now what I need to do is I need to solve the problem getting V2 by itself. So how do I get my variable V2 by itself? The opposite order of operation of multiplication is division. So I'm going to divide by what V2 is being multiplied by. So that means that V2 is going to equal the 202.6 times the 250 milliliters. And then I'm going to divide by what V2 is being multiplied by, 810.4 kilopascals. When you do that, some things to note is that kilopascals cancels out, and your unit of volume that you're left with is 250 milliliters, or excuse me, is milliliters. So I got for V2 that my volume was 62.5 milliliters, and that's your final answer. All right, let's go to the next problem in our set. This again is a Boyle's Law problem, so we're going to write down the exact same thing, P1 V1 equals P2 V2. So let's look for that initial set of conditions. It says a balloon starts off with a volume of 8 liters, so that's my V1, and a pressure of 12 atmospheres. So atmospheres is another unit of pressure, just like, again, when you have PSI for your pressure of the air in your tire. So atmospheres is, we would say if we are at sea level, we have 1 atmosphere of pressure of the Earth's atmosphere above us. But this is a lot of pressure. This is 12 atmospheres. So let's plug that in as our P1 and our V1. So we're going to have 12 atmospheres. The volume is going to be 8 liters. All right, now let's look for our pressure and volume after a set of conditions has changed. It says, what will be the new volume? So again, I'm going to solve for V2 in liters if the pressure is increased to 384 atmospheres. That is a huge increase in pressure. So let's go ahead and plug that in, 348 atmospheres. Let's get V2 by itself. So to get V2 by itself, I have to divide by what V2 is being multiplied by. So that means that I'm going to end up taking the 12 atmospheres and the 8 liters, and I'm going to divide them by what V2 was being multiplied by. So that was the 348 atmospheres. Atmospheres is going to cancel out. My unit of volume that I'll be left with is liters. So that means that V2, if you solve this, should be 0.28 liters. Let's make sure that makes sense. So for example, we know with Boyle's Law that they're an inverse relationship between pressure and volume. So as pressure goes up, we expect volume to do the opposite. It should go down. So notice that that is the case here. We start out with a pressure of 12 atmospheres. We went to a pressure of 348 atmospheres, and we should see that the volume should go down. And that's what we did observe. It started at 8 liters and it went all the way down to 0.28 liters. So that makes sense in terms of Boyle's law. Let's look at the next problem. We're going to start out with P1V1 equals P2V2. Again, we're going to be looking for that initial set of conditions when we start out the problem. It says a gas occupies a volume of 387 milliliters, so that's going to be my V1, at a pressure of 2.02 kilopascals. So again, that kilopascals is a unit of pressure. So let's plug that in as our P1 and our V1. So we've got that plugged in. Now we're going to be looking for our set of data after a change occurs. It says when the pressure is changed, okay, so that's saying that pressure is changed, the volume becomes 433 milliliters. What is the new pressure? So I'm going to be solving for pressure this time, and they tell me what the volume is, 433 milliliters. So to get P2 by itself, I'm going to need to divide by what P2 is being multiplied by. So I'm going to divide by 433. So to do that, I'm going to get P2 by itself. Let's take the 2.02 kilopascals, the 387 milliliters, and let's divide it by the 433 milliliters. So that's getting P2 by itself when I divide by what P2 is being multiplied by. Notice that milliliters is going to cancel out, and I'll be left with kilopascals as my unit of pressure. So P2 for this problem should be 1.81 kilopascals. Let's make sure that that makes sense. So in this problem, I want you to notice how volume started at 387 and it went up to 433. So if volume goes up, then that means that pressure should do the opposite, because Boyle's law is an inverse relationship. It should go down. So let's make sure that that's what happened. We started out with a pressure of 2.02 kilopascals, and we are correct. It did go down to 1.81 kilopascals. So our answer makes sense. So we're going to start talking about Boyle's law. Boyle's law, of course, is named after the scientist, and his last name Boyle, says that as pressure goes up, volume goes down. So because one goes up and the other goes down, we're going to say that this is an inverse relationship because they do opposite things. Pressure increasing and volume decreasing. It's kind of like if you were to take a balloon and squeeze it all the way around and it weren't allowed to pop, the volume would have to get smaller because you are compressing its gas molecules closer to each other. Boyle came up with an equation to show this, and it is P1V1 equals P2V2. There's a couple of key things to point out, and that is that the ones indicate an initial or starting set of conditions. And so if you don't know what the word initial means, it means starting. The twos symbolize after a change takes place what a final set of conditions are. And one of those is going to be missing, and we're going to use algebra to figure out what it is. Also notice that temperature is not mentioned. The reason for that is because it is remaining constant or unchanged during the problem. So we must assume that temperature remains unchanged in a Boyle's law problem. Take a look at this graph and notice that it says the same thing as this inverse relationship that we were talking about. As pressure increases, the volume gets smaller. So as pressure goes up, the volume also goes down. So this is a inverse relationship. Let's take a look at our first problem. It says, as a gas occupies a volume of 387 milliliters, so that'll be an important number, at a pressure of 2.02 kilopascals. All right, when the pressure is changed, so here's a change that's taking place, so we're going to go and look at our second set of conditions. The volume becomes 433 milliliters. What is the new pressure? So there's my question of what it's asking me to solve for in kilopascals. So here's my first set of conditions, and here is a second set of conditions with a pressure that I am missing and I'm asked to solve for. What we're going to do is we're going to look at our equation and we're going to write it down in our problem. P1V1 equals P2V2. We're going to plug in the information from the problem, and I'm going to color coordinate it so you can see where I circled it. So notice that the first pressure is 2.02 kilopascals. Remember, kilopascals is just a fancy unit for measuring pressure of a system. We could also be using atmospheres or millimeters of mercury. Then the first volume that goes along with that, 387 milliliters. Now we're going to set that equal to our second set of conditions, and I'm going to color coordinate that blue with what I circled. Remember, we're solving for pressure. It asks me what is the new pressure after the change takes place. So that'll be my unknown variable, and then I'm given the volume that went along after that change occurred, which was 433 milliliters. So I'll plug that in here, and now I'm going to solve the problem. We need to get P by itself. So what I'm going to do is it's just like solving for X, getting X by itself. If X is undergoing the operation of multiplication, then I'm going to do the opposite of multiplication to get X by itself, which would be division. So I'm going to divide both sides by 433 milliliters, and some cool stuff happens with our algebra there. As you know, this cancels out, but also as you plug this into your calculator, notice how milliliters cancels out and you'll be left with kilopascals, which is the unit of pressure that we were asked to solve for. What is the new pressure in kilopascals? So use your calculator and go ahead and find your answer. I calculated that the pressure would be much smaller, 1.81 kilopascals, and you can round to 2 decimal places. It's always good to ask yourself if your answer makes sense. So here, notice how the volume went the volume increased. It went from 387 to 433. So if the volume went up, we would predict that the pressure would go down because it's an inverse relationship. They do the opposite. Did that occur? Well, let's double check. The pressure started out being 2.02, and yes, it did. It did decrease. It went down to 1.81 kilopascals. So the other thing you want to make sure of while I'm making this video is that your units of pressure match. Notice how the unit, or sorry, not the units of pressure, the units of volume. Notice how the unit of volume here is milliliters. We want to make sure that that measure matches the unit of volume here, milliliters. If they were different, for example, milliliters and liters, we would need to convert them to be the same. So watch out for that as you solve your problems.